Okay, hello everybody. Today, as you can see, I changed a little bit the title of my presentation within the context of the dramatic development of the COVID crisis and the mass vaccinations that are currently ongoing almost all over the world. I wanted to draw your attention to something which is alarming. So please, first of all, don't consider me as an anti-vaxxer because I'm one of the most passionate vaccine guys on this world. You can check this, from my bio, from everything you find on LinkedIn about myself. But there is an important thing to say about these vaccines. And first of all, I would say these vaccines have been developed, and I'm talking about all of these vaccines, whether they are RNA-based, whether they are protein-based, whether these are viral vectors, it doesn't matter. These are prophylactic vaccines that, in fact, should be used in a conventional prophylactic setting, not in a pandemic setting. And I'm going to try to make clear why this is the case. So prophylactic vaccines typically are administered before an infectious exposure, before you get actually exposed to a high infection pressure. And that is, of course, first of all, to ensure full-fledged protection. I mean, as long as you have not full protection, you should not be exposed. That's clear to everybody. It's also to prevent exacerbation of disease. So imagine that you get vaccinated while you are incubating the virus or the disease. That can be catastrophic consequences. And there are examples of this, back in 2016-17 when Ebola patients were vaccinated. This was a ring vaccination trial conducted by WHO where inevitably, if you do ring vaccination, you will vaccinate people who are in the incubation, who are incubating the disease. If you do this then with, for example, live VSV vectors, you can imagine that this can have dramatic consequences. So another reason why you do this before exposure to high infectious pressure is to prevent immune escape. And so immune escape typically occurs when you have like suboptimal antibodies because you're still developing them and you are already exposed to the virus. So the virus has a potential there to escape the immune response because simply the immune response is not optimal. So what do we see now at the COVID crisis, which is pretty spectacular, is unprecedented. We have not seen this during previous pandemics. We first of all see several cases of severe disease due to highly infectious variants that have already occurred in young people. So young people typically, and especially young children, are well protected thanks to their innate immunity to several different types of coronavirus variants. And so now we see more and more, and I'm living in Belgium. We actually are seeing a huge wave now of these highly infectious variants, the UK variant, etc., occurring in teenagers, right? So that is not something that has typically been seen, during previous coronavirus pandemics. Another thing that is very striking is that we see several cases of COVID-19 vaccinated people who got the full course of the vaccine, so the two shots, and that are already shedding highly infectious variants. So those cases have been reported as well. So this already indicates that COVID-19 is indeed able to escape host immunity. As you will see in every textbook on vaccinology, even immunology, is if you allow virus replication, for example, on a background of suboptimal immune response, you will give the virus a possibility to escape the immune response, especially of course, if these are highly mutable viruses. So the current COVID-19 vaccine technologies, as I was saying, no matter what the manufacturing process is, all of them are targeted. That's the purpose of those vaccines, at inducing specific antibodies to the spike protein, and particularly the receptor binding domain that is localized within S1. And so, as a matter of fact, no one of them prevents really viral replication if the antibodies, of course, are, for example, too low, or if the affinity is too low. So, this is to say, because of their specificity, the high level of specificity, they are not able to control replication of variants that are actually circulating, that are more infectious. That was what I explained previously, because they are so, the immune response is so specific, and the variants are, of course, different from, have a spike protein that is already quite different from the one that was used in the vaccine. And so another thing is that they may not be able to prevent immune escape. This is especially the case, as I previously mentioned. You see fully vaccinated subjects and that are exposed to viral variants, and they allow already viral replication. Not yet the severe disease, but still viral replication and shedding. So are these vaccines safe? Yes, of course they are safe. I mean, I'm the first to say that they have been tested properly. They have been scrutinized by several people, but regulatory authorities have done a marvelous job, and I think there is no doubt about the safety of those vaccines. But this is all at the level of the individual. Are these vaccines safe? And I will illustrate you why I'm saying this in the upcoming slides. They are not safe at all if it comes to, if we talk about human populations that are exposed to COVID-19 pandemic. Please don't forget, what we are doing right now is that we are doing mass vaccinations in the heat of a pandemic, right? And same with the efficacy. Are these vaccines efficacious? I mean, we see all these discussions, 80%, 85, 92, whatever. Yes, they have a high level. Sorry? Was somebody trying to ask something? Okay, I continue. So are they efficacious? Yes, they are efficacious, again at the level of the individual. Are they efficacious for really fighting the pandemic in huge human populations? I will illustrate in my upcoming slides that this is highly questionable. I am convinced is not the case, but I will explain. So let's first have a look at the natural, without human intervention, the natural course of a viral pandemic, of a coronavirus pandemic. So I'm distinguishing always between two types of the population. The one population that is almost naturally protected due to innate immunity. And I will show you in one of the next slides that this is in fact due to killing of the virus through natural antibodies. And this killing is antigen non-specific. This is to say that this type of killing will work for all several different coronaviruses, including, of course, COVID and including all the variants. And so this killing is the combination of natural antibodies and NK cells. And there is increasing evidence now that people who are asymptomatically infected have high levels of NK cells in the blood. So there is increasing evidence that this is indeed the type of innate immunity that prevent these people from being ill, from getting severe disease. Whereas in the and you see the legend at the bottom of the slide, non-NACs, so these are all the other people. These are the people that, when exposed to COVID infection, they tend to develop severe disease. And they contract basically the disease because of weak innate immunity. We know all these people, especially the elderly, people with heavy underlying diseases, or other people that are otherwise immune suppressed. So and unfortunately some of these people die, but those who survive are typically going to develop antigen-specific neutralizing antibodies, and they will provide them with, of course, protection. again, when these antibodies start to wane, these people become again susceptible to disease. So we have somewhere the quite naive interpretation of the development of a pandemic, saying, well, we have a new coronavirus. We first have people with a weak innate immunity who get the disease, and when these people develop then an adaptive immunity, in case they survive, of course, they will only get susceptible to the disease once again when their antibodies start to wane, and that is when you see again outbreaks, etc. So there is a number of questions that we actually don't understand very well, and I'm essentially going to capitalize on the second question. So first question is, well, why does a natural viral pandemic comprise 3 waves? And I'll show you in the third slide that this is typically the case for a natural pandemic caused by an acute self-limiting viral infection. For example, coronavirus, you could also have enterovirus, etc. So why does the second wave typically hit the younger people? And why does the virus re-emerge to become seasonal after a pandemic? So let's have a look at the next slide, where, as I was saying, I would capitalize on the second question, why it primarily, the second wave hits the younger people. And you can see that not only it, and this is the example, of course, of the influenza pandemic in 1918, which is very often by experts considered to be a good example of actually a pandemic of an acute self-limiting disease. And typically, when the second wave hit the younger people, the younger age groups, and it was much more severe. And this has never been really well explained. So, of course, you would think, well, as the major source of the viral spread, and these are the people who are vulnerable to the disease, because, if you have the disease, you typically are going to transmit and spread much more virus. So for the virus, this is the interesting source of viral replication. This is the interesting reservoir for viral replication, when people get symptoms. But you can imagine, as more and more of these vulnerable people get the disease, etc., the capacity for the virus to replicate will diminish, because there will always be less vulnerable people. So at some point, the virus will need to shift to people who actually were naturally protected, and in one way or the other, make them more susceptible, so that the virus can now replicate and also make use of this reservoir. But this is not easy to understand. So the question is, how does that work? Why all of a sudden do these people become more susceptible, where I was just saying previously that they are normally naturally protected, not only against one single strain, but against several different variants? So therefore, it's important that we have a look at what is actually causing asymptomatic infection. Well, asymptomatic infection, we know that these people shed virus for a short time, so it's very short-lived. It's maybe a week or so. And then there is complete abrogation of the infection in those people that are naturally protected. And it is now increasingly clear that this abrogation is caused by innate immunity. So you have the COVID virus, you have the natural antibodies at the level of the upper respiratory tract, and these are IgMs that are complexing the virus. This virus is then internalized into dendritic cells, antigen-presenting cells, and they will present a pattern of non-antigen specific motifs. These non-antigenic specific motifs that have some similarity with self molecules will typically be recognized by natural killer cells. And that's why you see that natural killer cells in asymptomatically infected people will dramatically increase after they have cleared the infection. So because these natural killer cells are then, of course, capable of killing the epithelial cells that have been infected with the virus. So abrogation of this viral infection at an early stage, it's a very early stage of infection where the virus is still only replicating in the upper respiratory airway. It's the virus' secret weapon to ensure its own perpetuation. And why is this? Well, typically because the virus only replicates or is shed for a short time, also the immune response that will follow after this short-lived viral transmission and replication is also relatively weak. First of all, it's much weaker than, for example, in symptomatically infected patients, and it's also very important, it's very short-lived. But this, and so it's interesting to note that, so basically the antibodies that are generated after asymptomatic infection are not those that are responsible for clearing the virus. I just showed you that the virus is eliminated by natural immunity, the combination of the natural antibodies together with the natural killer cells. So it's not the goal or the purpose of these neutralizing antibodies was very mysterious. Nobody really knows, what is the purpose of these antibodies. They're short-lived and they are relatively weak. There is no boost. The titers are pretty low. Well, these short-lived antigen-specific antibodies, they are capable of suppressing the binding of coronavirus. I'm talking in general coronavirus because it doesn't matter when you talk about innate immunity and whether it is the original strain or whether it is the variant. These viruses can be bound by the multi-antigen specific IgMs. So these IgMs, these natural antibodies, are multi-antigen specific. So they are not antigen specific. But the antigen-specific IgGs, even if they are short-lived in an asymptomatically infected person, their avidity for the coronavirus is always higher than the avidity of the affinity of the IgMs for the virus. So in other words, as soon as you have antigen-specific IgGs popping up, they will outcompete the natural antibodies for binding to the virus. And so by doing this, they will, of course, dampen the innate immunity. They will not give a chance to these antibodies, the IgMs, to complex with the virus, and by doing so, to stimulate, to train the innate immunity, which has no memory, as you know. So, in fact, asymptomatic infection momentarily weakens the innate immunity, but without providing protective adaptive immunity, because, as I was telling you, I mean, the elimination of the virus is not done by the seroneutralizing antibodies, but it occurred before by innate immunity. So that is also the reason, or that also explains why the antibodies and the elimination occurs almost like simultaneously, or even the antibodies come a little bit later. Whereas if they would be functional in terms of eliminating the virus, they would need to come before, right? So by weakening now the innate immunity, automatically you will increase the susceptibility to the disease of these people who previously were naturally protected. So because what you do is that this transient increase in antibodies will all of a sudden suppress their innate immunity and hence make them more susceptible to disease. Remember, that is the reason why people originally with weak innate immunity are easily infected and get the disease. So what does this mean? Well, imagine if you now have increasing infection rates, and so people get increasingly infected during the pandemic, and this will clearly enhance innate immune suppression in people who are normally naturally protected. So how do you explain this? Well, it's quite simple. The more the infection spreads, and that is primarily the spreaders, the key spreaders are, of course, the people that get the disease, because if you get symptoms, you spread the disease. You spread it much more than the people do that are only asymptomatically infected. So if now you imagine that the infection spreads more and more people get infected, well, then the likelihood that the virus encounters somebody who is naturally protected just at the very time where he or she still has antibodies, because I told that they are short-lived, these antibodies are short-lived, increases. If the antibodies are only short-lived, well, normally if the infectious pressure is not high, the likelihood that you would have this transient increase of antibodies and just, encounter the virus is pretty low. The higher the infection rate, the higher the likelihood that somebody who is naturally protected will encounter the virus at the very moment where he happens to have this seroneutralizing antibodies. So that is to say that the more the virus has used the capacity of the people that have symptomatic infection to spread, the more this capacity is used, the more the capacity of the naturally protected individuals will increase. So there is a compensatory increase in the viral replication capacity, because now the naturally infected, the naturally protected individuals become more susceptible to the disease, and hence they are going to spread more virus. So in this way, the virus ensures propagation and ensures its persistence. So increased susceptibility rates in the naturally protected individuals suffices, in fact, to compensate for long enough. This is to say, what is long enough? Well, the virus just needs to persist till the vulnerable people who got the disease and who mounted antibodies start to lose their antibodies again. Because these titers are going to wane again, and then the virus can again infect those people and replenish its replication capacity. So that is how it shifts during a normal pandemic, I would say, to the younger people who are typically those that have that are naturally protected, and the elderly people, those who are the first that get infected because of weak innate immunity and will mount protective antibodies. So what happens now? So I explained to you what happens during normal pandemic and how the virus can perpetuate through this trick, in fact. So what happens now if we come with containment measures and all the infection prevention measures? Well, in one of my previous slides, I told you abrogation of viral infection at an early stage of infection is the virus' secret weapon to ensure its own perpetuation. Now, I'm adding to this, but still, it does this while leaving the door open for increasing its infectiousness when the infection rates drop. What does that mean? Well, if you come, of course, with severe, stringent, global, worldwide infection prevention measures, of course, you will give the virus a difficult time to spread and to transmit, so the infection rate will drop. And so how is the virus going to compensate for this? Well, he still has an opportunity. The virus has still an opportunity, and the opportunity is given by the asymptomatically infected people. How does that work? Well, as I told you, the virus replication in the naturally protected individuals is under control of the innate immune system. So what the virus can do at this moment, you have the virus is going to infect these people. They are going to mount antibodies in the presence, of course, of resistance of the innate immune system. Well, if the virus wants to replicate more, it needs to escape from this innate immune system, and it's going to introduce some mutations that enable to escape from the innate immune system. This is to say, these mutations will enable the virus to become more infectious. So the infectiousness of the virus is going to raise, to compensate for the lower infection rates that the virus was subject to due to human intervention. This is to say the prevention measures. So as I just mentioned, that enables the virus to increase the viral infectiousness in the naturally protected subjects. And that is what we are seeing right now. All of a sudden, we see popping up these highly infectious strains. There are, as you know, I'm not going to expand on this, but there are several of them. And you would say, okay, well, this trick is now going to enable the virus to compensate for this drop in infection rates that we impose to the virus for long enough. Well, again, long enough would mean till the people who were vulnerable have developed their protective antibodies are going to lose those antibodies. This is to say, for long enough till the antibodies drop in those, I call them the non-NACs, the vulnerable people who have developed antibodies. So, but then the question is, but what if these antibodies don't drop? So now, if you have these non-NACs, the vulnerable people with the antibodies, but the antibodies are sustained, they don't wane. How can that come? How is that possible? Well, this is possible, of course, if you vaccinate people. If you vaccinate people, you are going to generate a long-lived antibody titers, much longer than after natural infection. And so the virus cannot compensate then. Well, yes, the virus will become more infectious. That is the only weapon the virus has, because in the innate immune system, it can, of the NACs, it can escape to this immune system simply by introducing mutations in the S protein. It enables the virus to become more infectious. And this is going to continue till, I call this the return on escape mutations in this non-NAC, so in the vulnerable people, becomes relatively more profitable for the virus. So what does that mean? Okay, the virus can introduce mutations in the S protein, and to make, of course, the naturally protected individuals more susceptible. But of course, this has a limit. If that has happened in a large amount of people, then the capacity is limited again. So then the virus says, well, that is not says, but of course that is how it works. It becomes more profitable at that moment for the virus to introduce mutations that are going to resist the humoral antibodies in the people that have been vaccinated. Because now, if the virus succeeds in doing that, all of a sudden it increases its reservoir for augmenting the capacity of viral replication tremendously. So it was more or less had reached the limit, despite increasing infectiousness, in doing this in the NACs. But now, when indeed it succeeds in doing this in the non-NACs, but then really mutations directed against the vaccinal antibodies, then again a big reservoir becomes available for the virus. So that is where we are going to see escape mutations that are directed against the receptor binding domain, because that is what I started my talk with. This is what is especially targeted by the vaccinal antibodies, just to rebuild sufficient capacity to ensure sufficient viral replication. And that would mean that the resulting immune escape variants are resistant to the vaccine. So what I'm saying is that increasing infection or increasing seropositivity rates, so increasing seropositivity rates can be due to vaccination, of course, in people who are naturally vulnerable, and therefore is the first group that we vaccinate, for example, the elderly or immune-suppressed people. They will promote immune escape. So these enhanced rates will lead to innate immune suppression, because antigen-specific antibodies, as I told you, will outcompete natural antibodies for binding to coronavirus, and hence they will prevent the training of the innate immune system. But if this compensation is not sufficient, then, of course, the virus will escape to this innate immune response to be able to regain sufficient capacity. So we see that a selective immune escape in these naturally protected individuals will automatically lead to increased infectiousness. We are already seeing this right now. But this increased infectiousness, if it cannot go anywhere, because if despite this increased infectiousness, the capacity of the capacity for the virus to replicate in the naturally protected individuals continues to shrink, then of course it will be more profitable for the virus to start introducing mutations not randomly in the S protein, but in this specific domain, the receptor binding domain, because this is the one that protects now the whole cohort of vaccinated people, because these antibodies are specifically directed against this domain. So, I mean, if you look at the current COVID pandemic with human intervention, so I'm talking about, of course, the containment measures, I'm also talking about vaccination, we see already atypical courses of waves of the pandemic. It's not like what I showed you for flu, the natural pandemic. It's a completely bizarre picture what we see. So that is already pretty suspicious. But then, of course, the emergence of several much more infectious strains, frankly speaking, we have never seen this during a pandemic, that all of a sudden much more infectious strains are popping up. And then, of course, the quite scary finding that viral shedding in fully vaccinated subjects. So that is a situation. These people have high antibody titers. Nevertheless, they shed the virus. So the virus is able to escape to some extent. They are not getting the disease right now. But I mean, this is something which is very clearly evolving, because if now the virus manages to make these people ill despite their antibodies, then again it will gain a huge reservoir for viral replication capacity. So this is a kind of summary slide. So mass containment measures, because don't forget, we are doing this at large scale. We are doing this globally. And mass vaccination in the non-X accelerates immune escape, whereas mass vaccination of the naturally protected people would enhance the disease and the mortality rates in these people. And why is this? Well, as I was saying, if the naturally protected people, they develop a natural infection, well, they will just have short-lived antibodies. Short-lived antibodies that will just momentarily suppress their innate immune response, which momentarily makes them more susceptible. If now you're doing this on a permanent basis, you vaccinate these people, well, they will no longer have short-lived antibody titers, they will have long-lived antibody titers. So you are completely suppressing their innate immune system for a long time. So this is, of course, rendering these people not momentarily more susceptible, but durably more susceptible. So, in other ways, containment is, of course, going to favor to promote innate immune escape, and vaccination of non-NACs is going to promote innate immune escape in the NACs. That, of course, will lead to more infectious strains, and the more these strains become infectious, the more they can compensate for the loss of viral replication. But there is a limit, of course, because the reservoir of the NACs is not unlimited, and then it becomes more profitable for the virus to start to work on mutations in the receptor binding domain to regain a full capacity of the non-NACs who are no longer protected. So this is to say that, if needed, both NACs and non-NACs can serve as a potential source of immune escape upon human intervention in a natural coronavirus pandemic. Of course, you can imagine, if you first do this, that you make almost the virus so infectious that it can even succeed in escaping the adaptive immune response in the vaccinated people, and then afterwards you completely suppress the innate immunity in the people that are normally naturally protected, that is our younger generation, then of course you have a recipe for a major catastrophe, because you are going to fully unleash the highly infectious variants. So, and by that, people, I will end my talk, but I am more than concerned about this. And this is now something that is shared worldwide with all responsible health organizations, because don't forget, we do mass vaccinations with vaccines, and I'm not criticizing the vaccines that are good for prophylactic use, but since they cannot kill the virus, they cannot eradicate it, we drive immune escape in those different populations. And that is something to consider, because you do this at very large scale. I thank you for your attention, and I'm open for questions if you like. Thank you.